Dear students, this is part 3 video of motion in a straight line. In this class, first let us study how to calculate slope of the graph. For that, I considered displacement time graph. Here, graph nature is straight line passes through the origin. ಈ ಸ್ಟ್ರೇಟ್ ಲೈನಲ್ಲಿ ಎಲ್ಲಾದರೂ ಒಂದು ಪ್ಲೇಸ್ನಲ್ಲಿ ಸ್ಮಾಲ್ ಟ್ರಯಾಂಗಲನ್ನು ಫಾರ್ಮ್ ಮಾಡಿ, ಸೇ ಎ ಬಿ ಸಿ. ನಾವು ಸ್ಲೋಪ್ ಈಕ್ವಲ್ ಟು ಬಿ ಸಿ ಬೈ ಎ ಸಿ ಅಂದರೆ y component of the triangle divided by x component of the triangle, which is equal to. So ಈ ಗ್ರಾಫ್ ಪ್ರಕಾರ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಬಿ ಸಿ ಈಸ್ 40 minus 20 and value of AC is 4 minus 2, which is equal to 20 by 2 equal to 10. ಓಕೆ, ಈ ಸ್ಟ್ರೇಟ್ ಲೈನಲ್ಲಿ ಬೇರೆ ಪ್ಲೇಸ್ನಲ್ಲಿ ನೀವು ಸ್ಮಾಲ್ ಟ್ರಯಾಂಗಲನ್ನು ಫಾರ್ಮ್ ಮಾಡಿದ್ರೂ ಕೂಡ ಆ ಸ್ಲೋಪ್ ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಬರುತ್ತೆ. ಓಕೆ, ಸೊ ಯು ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ದಿಸ್ ಟ್ರಯಾಂಗಲ್ ಇಟ್ ಎನಿ ಪ್ಲೇಸ್ ಆಫ್ ದಿ ಸ್ಟ್ರೇಟ್ ಲೈನ್. ಓಕೆ, ಇನ್ ದಿಸ್ ವೇ we can calculate slope of the given graph. Next, this is 3 mark question. Show that slope of xt graph at any instant of time gives velocity of the body at that instant. For that, consider xt graph of body moves with constant velocity. In this graph, x1 and x2 are positions of the body at time t1 and t2 respectively. Means x1 is initial position of the body and x2 is the final position of the body. Okay. So here a triangle is formed ABC. So slope equal to BC by AC. According to graph, BC equal to x2 minus x1 and AC equal to t2 minus t1. Okay. Here x2 minus x1 is change in position of the body is called displacement. Okay. And t2 minus t1 is called as time interval or time. Okay. According to definition of the velocity, change in displacement with time is called as velocity. Hence the proof. Okay. Hence finally displacement by time equal to velocity. Okay. Next, acceleration. In Kannada, Vegoৎಕರ್ಷ. So we heard about accelerators in vehicles in day-to-day life. Yes, these accelerators are used to increase or decrease speed of the vehicle. Okay, so then what do you mean by acceleration? When velocity of a body is variable, then body is said to have an acceleration. Okay, ಅಂದರೆ ಆಬ್ಜೆಕ್ಟಿನ ವೆಲಾಸಿಟಿಯಲ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಅಥವಾ ಡಿಕ್ರೀಸ್ ಆದಾಗ ಆ ಆಬ್ಜೆಕ್ಟು ಎಕ್ಸಲರೇಷನ್ನ ಪಡ್ಕೊಂಡಿದೆ ಅಂತ ಹೇಳ್ತೀವಿ. ಎಕ್ಸಲರೇಷನ್ ಈಕ್ವಲ್ ಟು ಚೇಂಜ್ ಇನ್ ವೆಲಾಸಿಟಿ ಬೈ ಟೈಮ್ ಇಂಟರ್ವಲ್. ಹಿಯರ್ ಎಕ್ಸಲರೇಷನ್ ಈಸ್ ಡಿನೋಟೆಡ್ ಬೈ ಸ್ಮಾಲ್ a ಈಕ್ವಲ್ ಟು v2 minus v1 by t2 minus t1. v2 minus v1 is change in velocity. It can be denoted as delta v. Okay, here v1 is the initial velocity and v2 is the final velocity of the body. Okay, and t2 minus t1 can be written as delta t. Okay, hence acceleration is defined as rate of change of velocity with time. Okay, here acceleration is a vector because it has both magnitude and direction. Next, SI unit of acceleration is meter per second square. From this formula, we can write here delta V, that is change in velocity, is measured in meter per second. Okay, and delta T, that is time interval, it is measured in terms of second. Hence, which is equal to meter per second square. Okay, right? So, SI unit of acceleration is meter per second square. Next, types of acceleration. First one, uniform or constant acceleration. A body is said to have an uniform acceleration if its velocity changes by equal amounts in equal time interval. ಓಕೆ, ಅಂದರೆ ಈಕ್ವಲ್ ಟೈಮ್ ಇಂಟರ್ವಲಲ್ಲಿ ವೆಲಾಸಿಟಿ ಈಕ್ವಲ್ ಅಮೌಂಟಲ್ಲಿ ವೇರಿ ಆದರೆ ನಾವು ಅದಕ್ಕೆ ಯೂನಿಫಾರ್ಮ್ ಎಕ್ಸಲರೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಮೀನ್ಸ್ ಐದರ್ ವೆಲಾಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ಬೋದು ಅಥವಾ ಡಿಕ್ರೀಸು ಆಗಬಹುದು. ಓಕೆ, ನೆಕ್ಸ್ಟ್, ಸೊ ಎಕ್ಸಲರೇಷನ್ ಮೇ ಬಿ 0 or positive or negative. Suppose the velocity of the body is constant. ಅಂದರೆ ಒಂದು ಆಬ್ಜೆಕ್ಟು ಯೂನಿಫಾರ್ಮ್ ವೆಲಾಸಿಟಿಯಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದ್ದರೆ ಆಗ ಅದರ ವೆಲಾಸಿಟಿಯಲ್ಲಿ ಯಾವುದೇ ಥರ ಚೇಂಜಸ್ ಇರೋದಿಲ್ಲ. ದೆನ್ ಎಕ್ಸಲರೇಷನ್ ಈಸ್ 0. ಸಪೋಸ್ ದ ವೆಲಾಸಿಟಿ ಆಫ್ ದಿ ಬಾಡಿ ಈಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್, ದೆನ್ ದ ಎಕ್ಸಲರೇಷನ್ ಈಸ್ ಪಾಸಿಟಿವ್. ಲಾಸ್ಟ್ ಒನ್, the velocity of the body is decreasing, then acceleration is negative. Okay, remember these points. Next, consider 3 cases here regarding the direction of acceleration. First one, direction of acceleration is same as that of velocity. Magnitude of velocity increases, then acceleration is positive. ಓಕೆ, ಎಕ್ಸಾಂಪಲ್, ಬಾಡಿ ಫಾಲಿಂಗ್ ಅಂಡರ್ ಗ್ರಾವಿಟಿ. ಅಂದರೆ ಒಂದು ನೀವು ಸರ್ಟೇನ್ ಹೈಟಿಂದ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಫಾಲ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಇಮ್ಯಾಜಿನೇಷನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಆಗ ಇಟ್ ಈಸ್ ಅರ್ತ್ ಸರ್ಫೇಸ್. ಓಕೆ, ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಫಾಲಿಂಗ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್, ಹೌದಾ, ಟುವರ್ಡ್ಸ್ ದಿ ಅರ್ತ್. ಸೊ ದಿಸ್ ಈಸ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ವೆಲಾಸಿಟಿ. Okay, then direction of acceleration is also acting in the same direction. Okay, ಅಥವಾ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದಿ ಎಕ್ಸಲರೇಷನ್ ಕೂಡ ಯಾವ ಡೈರೆಕ್ಷನಲ್ಲಿ ವೆಲಾಸಿಟಿ ಆ್ಯಕ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಅಲ್ಲೇ ಇರುತ್ತೆ. ಓಕೆ, ಹೀಗಾಗಿ ಈ ಎಕ್ಸಾಂಪಲ್ ಏನಾಯಿತು ಅಥವಾ ಈ ಕೇಸಲ್ಲಿ ಏನಾಗಿದೆ, ಡೈರೆಕ್ಷನ್ ಆಫ್ ಎಕ್ಸಲರೇಷನ್ ಈಸ್ ಸೇಮ್ ಆ್ಯಸ್ ದಟ್ ಆಫ್ ವೆಲಾಸಿಟಿ. ಯು ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ದ ಅನದರ್ ಎಕ್ಸಾಂಪಲ್, the car is speeding up. ಅಂದರೆ ಇದರಲ್ಲಿ so here, so a moving car increases its velocity. Okay, speeding up ಅಂದರೆ it increases its velocity. Then the direction of the velocity and direction of the acceleration both are same. Okay, so in this case acceleration is positive. Okay, next, consider case 2. Direction of acceleration is opposite to as that of velocity. Magnitude of velocity decreases, then acceleration is negative. Okay, negative acceleration is called retardation or deceleration. Example, stone thrown vertically upwards. Okay, again consider diagram. This is earth surface. ಸೊ ಆಬ್ಜೆಕ್ಟನ್ನು ನೀವು ವರ್ಟಿಕಲಿ ಅಪ್ವರ್ಡು ಥ್ರೋ ಮಾಡಿದ್ದೀರಾ, ಅಂದರೆ ಈ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ಸ್ಟೋನು ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ಹೌದಾ. ಸೊ ದಿಸ್ ಈಸ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ವಿ. ಆದರೆ ಇಲ್ಲಿ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಎಕ್ಸಲರೇಷನ್ ಯಾವತ್ತೂ ಹೀಗಿರುತ್ತೆ, ಇಟ್ ಈಸ್ ಟುವರ್ಡ್ಸ್ ದಿ earth. So this is direction of acceleration. Okay, ಇಲ್ಲೇನಾಗಿದೆ ಹೇಳಿ, direction of velocity is opposite to direction of acceleration. ಆಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಈ ಆಬ್ಜೆಕ್ಟು ವರ್ಟಿಕಲಿ ಅಪ್ವರ್ಡ್ ಮೂವ್ ಆಗಬೇಕಿದ್ರೆ ಅದರ ವೆಲಾಸಿಟಿ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಹೀಗಾಗಿ ಎಕ್ಸಲರೇಷನ್ ವಿಲ್ ಬಿ ನೆಗೆಟಿವ್. Again you can consider the another example. This car is slowing down. Means here a moving car decreasing its velocity. Okay, then acceleration is acting opposite to that of velocity. Okay, then the acceleration is negative. Okay, next third case, direction of acceleration is perpendicular to velocity. Example, uniform circular motion. Okay, here consider the second diagram. In this diagram, the red color arrow mark represents velocity and blue color arrow mark represents acceleration. Okay, so during circular motion, at each point acceleration is perpendicular to direction of velocity. Okay, means here ಇಲ್ಲಿ ಆ್ಯಂಗಲನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಎಕ್ಸಲರೇಷನಿಗೆ ಮತ್ತು ಡೈರೆಕ್ಷನ್ ಆಫ್ ವೆಲಾಸಿಟಿಗೆ ಆ್ಯಂಗಲ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅದೆಷ್ಟಿರುತ್ತೆ, 90 ಡಿಗ್ರಿ. ದಟ್ಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್. ಓಕೆ, ಹೀಗಾಗಿ ಇನ್ ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ acceleration is always perpendicular to direction of velocity at each point. ಪ್ರತಿಯೊಂದು ಪಾಯಿಂಟಲ್ಲೂ ಕೂಡ ಸೇಮ್ ಸಿಚುವೇಶನ್ನೇ ಎರೈಸ್ ಆಗುತ್ತೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಟೈಪ್ ಈಸ್ average acceleration. A body is said to have an average acceleration if its velocity changes by unequal amounts in equal time interval. Okay, right, here average acceleration can be written as change in velocity by time interval. Average acceleration is denoted by a bar equal to v2 minus v1 by t2 minus t1 equal to delta v by delta t. ಓಕೆ, ಇಲ್ಲಿ ಈಕ್ವಲ್ ಟೈಮ್ ಇಂಟರ್ವಲಲ್ಲಿ ಒಂದು ಆಬ್ಜೆಕ್ಟಿನ ವೆಲಾಸಿಟಿ ಅನ್ಈಕ್ವಲ್ ಅಮೌಂಟಲ್ಲಿ ಚೇಂಜಸ್ ಆಗ್ತಾ ಇದ್ದರೆ, ಓಕೆ, ಒಮ್ಮೆ ಡಿಕ್ರೀಸ್ ಆಗೋದು, ಒಮ್ಮೆ ಇನ್ಕ್ರೀಸ್ ಆಗೋದು, ಒಮ್ಮೆ ಸ್ವಲ್ಪ ಅಮೌಂಟಲ್ಲಿ ಡಿಕ್ರೀಸ್ ಆಗೋದು, ಇನ್ನು ಮತ್ತೆ ಹೆಚ್ಚು ಅಮೌಂಟಲ್ಲಿ ಡಿಕ್ರೀಸ್ ಆಗೋದು, ಅಂದರೆ ಅದು ಅನ್ಈಕ್ವಲ್ ಅಮೌಂಟಲ್ಲಿ ಏನಾಗುತ್ತೆ, ವೆಲಾಸಿಟಿ ಚೇಂಜಸ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಓಕೆ, ಆ ಸಿಚುವೇಶನ್ ನಾವೇನು ಮಾಡ್ತೇವೆ, ಎವರೇಜ್ ಎಕ್ಸಲರೇಷನನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೇವೆ. ಓಕೆ, ನೆಕ್ಸ್ಟು ಥರ್ಡ್ ಒನ್, ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಎಕ್ಸಲರೇಷನ್. It is acceleration of a body at any instant of time. It is denoted as A instantaneous equal to limit of delta V by delta T as delta T tends to 0 equal to dV by dt. Okay, here delta V is change in velocity occurs in extremely small time interval delta t. Okay, so remember these three types of accelerations, their definitions and their formula. Okay, next, velocity time graph. The graph in which velocity is taken along y-axis and time is taken along x-axis. Okay, first one, body moves with uniform velocity or zero acceleration, right? Okay, in this case the body moves with velocity 20 meter per second initially. Okay, ಇಲ್ಲಿ ಇನಿಷಿಯಲಿ ಒಂದು ಆಬ್ಜೆಕ್ಟು 20 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಓಕೆ, ಹೀಗಾಗಿ ಎಟ್ ಅ ಟೈಮ್ t ಈಕ್ವಲ್ ಟು 0 ಸೆಕೆಂಡ್ the velocity of the body is 20 meter per second. So after 5 seconds the velocity does not changes, it remains same. Okay. Next, so after 10 seconds, again there is no change in velocity. So it is continued for 15 second, 20 second and 25 second. Okay. So now joining these points, we get straight line parallel to x-axis. Okay, straight line parallel to x-axis. So this is the graph nature. Okay, right. ಸೊ ಇಲ್ಲಿ ಯೂನಿಫಾರ್ಮ್ ವೆಲಾಸಿಟಿಯಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದರೆ ಅದರ ವೆಲಾಸಿಟಿ ಯಾವುದೇ ಥರ ಚೇಂಜಸ್ ಇರೋದಿಲ್ಲ. ಓಕೆ, ರೈಟ್. ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಒನ್, ಬಾಡಿ ಮೂವ್ಸ್ ವಿತ್ ಯೂನಿಫಾರ್ಮ್ ಪಾಸಿಟಿವ್ ಎಕ್ಸಲರೇಷನ್. ಪಾಸಿಟಿವ್ ಎಕ್ಸಲರೇಷನ್ ಮೀನ್ಸ್ ಇಲ್ಲೇನಾಗಬೇಕು, ಸೊ ವೆಲಾಸಿಟಿ ಈಸ್ increases in equal amounts in equal time interval. Okay, right. So in this example, the body is at origin O at t equal to 0 second. Okay, so at 1 second velocity is increases to 10 meter per second. Again at 2 second the velocity is increases to 20 meter per second. At 3 second again velocity is increases to 30 meter per second. It is continued. Okay, at each time the velocity is increases in equal amounts of 10 meter per second. Will you agree? Here if you calculate the change in velocity, in first case 10 minus 0. Okay, in second case equal to 10. In second case 20 minus 10 equal to 10. Third case 30 minus 20 equal to 10. ಎಸ್, ಹೀಗಾಗಿ ಎಟ್ ಈಚ್ ಸೆಕೆಂಡಲ್ಲಿ ಕೂಡ ಏನಾಗಿದೆ, 10 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಷ್ಟು ವೆಲಾಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. ಅಂದರೆ ಈಕ್ವಲ್ ಅಮೌಂಟಲ್ಲಿ ವೆಲಾಸಿಟಿ ಈಸ್ ಇನ್ಕ್ರೀಸ್ಡ್. ಓಕೆ, ಸೊ ಜಾಯ್ನಿಂಗ್ ದೀಸ್ ಪಾಯಿಂಟ್ಸ್ ವಿ ಗೆಟ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್ passes through the origin. Okay, next, body moves with uniform negative acceleration. Negative acceleration means the velocity is decreases in equal amounts in equal time interval. Okay, so consider an example, so at which the body moves with the velocity 40 meter per second initially. Okay, means at 0 second the velocity of the body is 40 meter per second. So at 1 second the velocity of the body is decreases to 30 meter per second. At 2 second the velocity is decreases to 20 meter per second. At 3 second the velocity is decreases to 10 meter per second. Finally the body comes to rest at a time t equal to 4 second. Okay, right. So here also the velocity is decreased in equal amount. Yes, 40 minus 30, 10. 40 minus 30 equal to 10. Yes, similar way 30 minus 20 equal to 10. Yes, so it is continued. So at each time the velocity is decreases by 10 meter per second. Okay, right. Next, body starts with initial velocity and moving with uniform acceleration. Okay, right. So in this case, the initially body moves with some velocity. In this example, the initial velocity of the body is 5 meter per second. Okay, at 1 second means at time t equal to 0 second, the velocity of the body is 5 meter per second. At 1 second, the velocity is increases to 10 meter per second. Okay, next at 2 second, again velocity is increases to 15 meter per second. It is continued. Here also each time velocities increases in equal amount. Okay, so finally the velocity becomes 25 meter per second at 5 second. Yes, at 5 second the velocity is 25 meter per second. So after joining these points, so we get straight line with intercept. Okay, right. Next, so ಎಕ್ಸಾಮಿನೇಷನಲ್ಲಿ ನೀವು ವೆಲಾಸಿಟಿ ಮತ್ತು ಟೈಮ್ ವ್ಯಾಲ್ಯೂಸನ್ನು ಮೆನ್ಷನ್ ಮಾಡಬೇಕು ಅಂತಿಲ್ಲ, ಜಸ್ಟ್ ಗ್ರಾಫ್ ನೇಚರ್ ಈಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ಫಸ್ಟ್ ಗ್ರಾಫ್ ವೆನ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಮೂವ್ಸ್ ವಿತ್ ಯೂನಿಫಾರ್ಮ್ ವೆಲಾಸಿಟಿ ಆರ್ ಝೀರೋ ಎಕ್ಸಲರೇಷನ್. ಸೆಕೆಂಡ್ ಒನ್, ದ ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ಸ್ ವಿತ್ ಯೂನಿಫಾರ್ಮ್ ಪಾಸಿಟಿವ್ ಎಕ್ಸಲರೇಷನ್. And third one is the object moves with uniform negative acceleration. And last one is the body starts with initial velocity and then moves with uniform acceleration. Okay, so these graph natures are important. Again, this is 3-mark question. Show that area under VT graph is equal to displacement of the body at that instant of time. For this, consider a graph of body moves with uniform velocity. Okay, here A and B are 2 points corresponding to time t1 and t2 respectively. Okay, but here the velocity is constant or uniform or same. Yes, okay. Here given that area under VT graph. So first calculate this value, which is equal to, here a rectangle is formed. Yes, hence area under VT graph equal to area of rectangle ABCD, which is equal to length into breadth, that is equal to AC into CD. Okay, so AC value is, according to this graph, V minus 0, that is V, and CD is T2 minus T1, that can be written as delta T. So V into delta T equal to delta X, because we know according to definition of velocity, V equal to delta X by delta T. Will you agree? Yes. So here delta X is displacement and delta T is time. Yes, velocity V equal to delta X by delta T. Hence here V into delta T is there, that can be written as V into delta T equal to delta X. Here delta X is displacement, hence the proof. Next, the another one, show that slope of VT graph is acceleration of a body at that instant of time. So consider VT graph of a body moves with uniform acceleration. Okay, so for this you can consider either this graph or this graph to calculate slope. Okay, here I considered the fourth graph. So here what is given? Slope. So calculate slope here. Slope equal to, here triangle is formed, that is DEC. Here V1 is initial velocity of the body and V2 is the final velocity of the body at a time T1 and T2 respectively. Okay. Hence slope equal to DE by CE, D equal to V2 minus V1 and CE equal to T2 minus T1. V2 minus V1 can be written as delta V and T2 minus T1 can be written as delta T. According to definition, change in velocity with the time is called as acceleration. Hence the proof. Thank you.